So this is our propeller hub, and the reason why we started dismantling it, it was the wear measurements were out of the limit. So this is our blade carrier, and this is our propeller hub. Okay, so by the movement of the blade carrier, the bearing surface is getting weighed out. So every 5 years we measure our wear measurements, and if they exceed the limits, we start dismantling the propeller shaft like this. So we can make some rectification and maintenance of the propeller hub. So this is our propeller hub, and this is our shaft. Now we will remove the propeller hub from the propeller shaft in order to inspect and measure internal parts, so we can install some repair solutions. Here you can see our servo oil pump, which provides us hydraulic oil for giving the pitch to propeller.
What is this?
This is our servo oil piston. The hydraulic oil for the head oil is accumulating behind of this piston. So piston is moving like up direction. So our vessel will be going to astern.
Okay.
And it goes the other way around for the head. The hydraulic oil accumulates in front of the piston this time, and the piston moves to the front side, which means that our vessel will be going to ahead.
CPP control movement, that is a...
Exactly, it's provided by this piston. Basically, we
this
can
the
say
name is piston, right?
Yes, servo piston.
So piston, and these two studs are there to studs you put to take it out, to remove this.
Yes, exactly, to balance its weight. Actually, these two studs to balance it.
Balance it, and this is fitted inside that propeller hub, correct?
Yes, exactly, and
It
here
is-
you can see our servo oil cylinder.
This is servo oil cylinder, yeah. This
So
one.
our piston is moving inside of this one. You can see the pitch movement to the vessel, or
Right.
to the blades, we can say.
Okay, and this is the end point, and this end point of the propeller shaft
Exactly.
is connected in the engine room
In the engine room via hydraulic coupling.
via hydraulic coupling. That is a muff coupling. You
Muff
can say.
coupling, like we can say.
You can say it's connected to the muff coupling, yeah.
Exactly, and via muff coupling, this propeller shaft is connected to reduction gear shaft,
All right, reduction gear, yes.
and then afterwards the crankshaft. Yeah, we can say. Yeah?
Yes. And this push-pull rod,
Yes, exactly.
this goes inside this.
Yes, exactly. This whole pipe is inside of the propeller shaft,
Yes.
which provides our hydraulic oil for pitch movement. I can explain you on
Yes.
plates. Okay. Normally they have, for example, this one 10 millimeter thickness. Okay. After machining the blade carrier. Okay. And
Blade carrier,
machining
yeah.
the propeller hub on the inside. So by adding shims behind this guide plates, they just wanted to tolerate the gap after the machining.
Okay.
But this is not a normal procedure.
Okay.
Adding behind shims to these guide plates is not normal.
Okay.
Now after the measurements that we took yesterday, we saw that the blade carrier and hub is machined.
This is machined also, yeah.
Yes,
Previously somebody, yeah.
This one is machined and this one is machined already.
This is also machined, yeah, already, yeah. Means somebody previous owner has machined this, correct?
Yes.
So let's see, okay.
We cannot know who did it, but it's machined according to measurements.
So you mean to say this brass plate is extra? Somebody has put extra plate here, correct?
Under that one.
Under that one.
Under that one.
So under that,
That yellow part is original supplied by MN, but somebody put some thick plates behind that bar. Okay. You
behind
can
this.
also see if you record the video. You see the thickness of the shim.
Yes. There's some shim is there, yeah.
Yes. And
So-
also behind this one.
So basically, this is a propeller. This is a shaft propeller, unit, yeah, which is hydraulically.
Yes. This is
turned.
the part that moves the blade carriers and propeller blades.
Right.
We have to polish all the grooves
Yeah.
and take measurement afterwards.
Okay.
But we need to keep 80% of contact surface.
At the end, yeah. Okay. And at the bottom, what you said, like
Here, very big groove.
It's a big groove here, yeah?
Very big.
On the shaft, yeah? So what is the plan for repair like this?
Polishing,
Uh-huh.
and after that we measure.
We measure this.
We make a measure report.
So-
Also polishing here.
This surface, yeah?
Yeah, the surface has to be like this, all around, like this.
Like this, yeah?
Yeah.
But we are not afraid of losing the surface, correct? So,
No, I'm not afraid of it, but we have to be sure.
so but this is not a very critical area,
You
yeah?
have to keep 80% of intact.
Intact, yeah? Okay. This is die penetration test. You have done it. It's a blade carrier NDT test is going on. It's a blade carrier. And this is a shaft which is all dismantled condition. The guy is doing it. Yeah, means because this is a main key pin which is controlling your blades, you know, movement, you know, and that's why NDT test has to be done, you know. Here, yes. It's an NDT test of the shaft at the engine room side. The engine room, the guy is doing NDT test.
Channel thing.
Yes, yes, yep. So this is magnetic test is going on. So there has to be vibration, correct? This magnetic test.
Vibration of the magnetic particles, yes.
Magnetic particles, yeah. So if there's a crack, so it will just vibrate more, yeah.
Yes. Yes. The magnetic particles will accumulate inside the crack.
Inside the crack. So it will just press it and you'll see the
We
hairline.
will be
Yeah?
able to see
See
it.
the hairline, yeah.
Aynen. Yes. Usta şu an o sonradan sıktığında senin manyetik partiküller var, doğru mu? İlk sıktığında değil.
These are the boards for the CPP. Die penetration test is going on with the magnet particle test. The iron is there and the magnet is there. So we're spraying the iron and then we will test the crack on these boards. Blade measurements in progress. Now this is a pitch control unit. He is doing MPI test here on the pitch control unit. On the pitch unit, you know.
Oradan 40 santim böyle gel. 40 santimden sonra yine.
Machine more than 6 mm here. I can put one flange. Inside the shrink fit will be here. Outside it will be o-ring groove. If you can show me drawing what I draw.
So the spacer was supposed to come till here.
Until come here somewhere. Until come here somewhere.
Yes.
And there is a
step.
thickness,
One step. One step
has to be there.
Yes.
With 6 mm height, 6 mm depth.
Yes.
And the flange will come inside of this one, according to MIN drawing. Okay. Now it is missed.
Now this step has missed, so
The
we
only
forgot
step
it.
is
Step
step
missed
is-
and we grind off that full.
We machined.
That full
from
surface.
here to here.
From
We
here to here.
machined.
Yes. So it was one side, only one side is a mistake, otherwise others are intact. Others are intact.
Once they're all in place, you drill through and cool it down and put it in.
So these are the rings for what purpose? These are for radial.
This is for the hub outside. This is for inside. And this one here is for the bore, the middle.
For the bore, huh?
Yeah.
For the middle part, yeah?
And these small one here
Yeah.
is for the O-ring, for the seal groove.
For the seal groove, yeah? So it's a similar here, yeah? Same is,
That's a big one. That's for the bore.
so the bore,
The center one for the bore.
it's also 4 windows or 3 windows?
Yeah, but there's one here and another one there. They took it out to see.
Yeah, 4. We have 4 here.
Everything is here.
It's full set of repair set for the CPP, yeah? Full set, one set for the repair.
yeah.
And this is a approved procedure
Yeah.
by the class to repair the hub, yeah?
Yeah.
This kind of repairs, yeah, which is going on there, yeah? And this
And the additional one is being shipped tomorrow.
additional, tomorrow they are going to ship, yeah?
At the ship, they make a mistake. So we need a special ring. And they're gonna ship it tomorrow.
Tomorrow, so maybe
Maybe here Thursday, I think.
we are going to get it. This is the workshop in Turkey. We came for Turkey for this repairs. So you can see it's a full industrial area, and these are workshops which are in Turkey. This is another mechanical workshop. This is another mechanical shop, and this is where CPP hub propeller job is going on. You can see the guys are working here. These are the instruments they are building. So they are doing the window. This is the CPP hub job. This is CNC machine. But Turkey this time. This is another project which is going on. You can see. There you can see the kind of CNC machine they are doing it. And device they are using to build it. Yeah, can you brief me about what is going on right now?
So when once we receive it, one window was machined, and as far as I know, you will bring a new plate for this surface.
Yeah.
This is the window that has been machined previously.
Okay.
So we machined inner diameter,
Inner diameter. Okay.
inner diameter,
Yeah.
and for all other 3 windows, we machined inner diameter also. And this surface,
Inner is this. Yeah. Okay.
yeah, inner diameter.
Okay.
This surface and the back surface,
Yeah.
and here,
Yeah.
here the groove diameter.
Okay.
We machine them all roughly. Approximately. So 1.5 machining allowance still there.
Okay.
First we go roughly because it saves time, you know.
Okay.
After all rough machining is finished, we will start for fine machining.
Fine machining.
Final machining, yes.
So
Now it is being machined the backside. See?
backside.
See, there is also wear on it.
Yeah.
It is not. The cutting bit didn't touch the area. So we have nearly 4 millimeter machining still there.
4 millimeter machining inside. Yeah. In this side. Yeah. This.
Yes, that lateral surface.
Okay. Okay. And this fine machining you will be doing here or
Yes,
this
here.
here only. Yeah.
Yeah.
So it's just
On that machine.
Okay.
Also drillings. There are many drills. 8 hole,
8 holes. Yeah.
8 hole for each window.
Yeah.
8 hole radial holes.
Okay. 8 holes this side, 8 holes this side.
Yeah.
And then you install the stud.
Yes.
And on stud, then when you put the ring here,
Yes.
it will also have same similar holes, and it will fit in.
Yeah.
shrink fit, yeah?
There are some bushes. Hans also lives in.
They do the final machining.
Yeah.
They're going to put to do all the way around.
Final round, yeah.
For turning,
Right.
not for milling.
Okay.
And this is only for the rough cut. The fine cut will be drilling.
Right.
Yeah.
So, the machining process and everything is like still okay, right?
Yeah.
And Hans, what about this surface and that surface on top? No machining, yeah?
No.
So basically the water which was leaking from the hub, so you suspect that the O-ring was the main issue, yeah?
Yeah.
O-ring groove was the main issue, yeah? Because of which the water was leaking there, yeah?
And the wear from the hub.
And we are from the hub.
Yeah.
We are from the hub, you mean to say which side? Outer face or inside face? Which was the main reason for the water ingress?
It's a.
As per your opinion, you know.
It's the seams here, but when everything is worn, everything gets more tendency to leak.
Okay, so you mean to say the seal, the O-ring which is sitting here, maybe that is the reason, right?
Yeah.
Yeah, and then some previous owner, they've already done a machining and there was more wear down. So that's why we had to do this job, correct? Yeah. Okay. Now this is, we are boxing up the propeller and the hub is getting mounted. And this is full mounting going on the shaft. So we are boxing up this end cover with this hydraulic pump. So the hub looks like this from the end. So this will be mount, they will mount the cover here, and then this is sealed. This they are fabricated from here. They have fabricated this from here. And this is the muff coupling flange. Full flange is here, new muff coupling flange which was damaged, and there is a muff housing here. Yeah. So this is the bolt, yeah? Bolt inside?
Bolts are inside.
Can I see? Can I have a look? These are the bolts. Yeah, these are the bolts. Okay. These are 12 pieces of bolts, yeah. Okay.